So, everybody got a laptop and logged into Schoology. This is Prohaska, for those of you who don't know me. I typed up some information. I have this on Schoology, but I wanted you to have it in hand as well because it's just some information that you're going to be coming across and I'm going to be talking about, and you're going to really be using it more once you get into your projects and when you're in your biomedical classes. But I'm not going to have a lot of time to go into this deeply like you will in your science classes, but I figured I'd have it on the paper to give you some definitions as to some of the things you'll be looking for. Mean, sums, standard deviation, standard error, error bars on graphs. You'll be seeing all of this once you get into your, especially the ninth graders, into the ag classes. Kimmy, when did you start using some of this? In your regular ag class? Or was it more the biomedical?
I haven't taken bio yet, but it was during ag class when we had to work with, I think, flies and oranges.
Is that a ninth grade course? So some of you may have had it already, but others have not. And it's something that Mr. Seifert and Mr. Searfoss is looking for, and Ms. Shade, when you're taking their course. So this is going to be kind of fast, but it's just an overview. I'm going to be teaching statistics this year in the high school. Mrs. Schaefer retired, so I'll be teaching it. But I have never taught statistics, and I haven't had statistics since I've been in college. So I actually had to reteach myself some things, and you know where I found a lot of it? Like I said, YouTube. Yeah, just look it up on YouTube to figure it out. So if there's anything that you missed or you think I didn't get what she said, it'll be on, you can look it up on YouTube. And some are way more advanced, and some YouTube videos are very, very basic. So it's a really good resource. So what I did was, in the resource folder, which is over here on the side underneath members, you just click on that. Seminar Summer 2018, click on that. And then statistical analysis. I'll click on that. And what I have there is all three levels. So you would be under level 2. And the paper that I just handed out to you, that's the Word document. So you already, it's right, what I handed out to you is on Schoology if you lose the paper, but if you want to write on it, it's right there. But the other thing I gave you is this student file in Excel. So you want to click on that. And I think it takes a little bit longer to open up on your page than it does on mine, so I'll wait a little bit. I've already set a file up for you. Everybody got it? No, and it takes a little longer. You will have to put your information in yourself when you're using Excel, but since we only have about an hour, I didn't want you to have to spend time typing in the data. I would rather you practice writing the formulas and calculating things than typing numbers in, because I think everybody can type. I mean, you all can type numbers in, I know that. And you're going to download it so we can get in Excel so that we can actually work in it. So we'll come over here to the arrow, we'll download, and we'll open it up in Excel. And you don't have to worry about saving it or anything because that file is always going to be in Schoology, so you'll have it in there. I don't know where yours opens up. There's 4 tabs at the bottom. Well, you want to go to the left most tabs, sum, mean, and standard deviation. So that's what you want to go to. So let's just say that these trials, I made this up in the morning. I said, let's say I did 4 trials of 1, 2, 3, 4, 5, 6 students in each trial. And I wanted to see in a minute how many, first I said push-ups somebody could do, but I thought, ooh, is 55 a lot of push-ups to do in a minute? That sounds like a lot. So then we changed it to sit-ups. Because you could probably do 55 sit-ups in a minute, right? I think I could. I'll try that. So let's just say that's what the data is. So let's say you wanted to find some information out about that. I set this up for you so that I can clearly say, let's start with the yellow trial, and it's easier for you to see. When you open up an Excel spreadsheet, it's just blank. It's just empty cells, and then you would have to design it, but I've already done that for you. So one of the very first things you want to do, and some of this you may know how to do, and you may know quicker ways, I'm just going to try to be basic. But the first thing I'm going to have you do is find the sum of that first trial. Now normally you would just add them all up with your calculator. You can get the computer to do that for you, get the program to do that for you. So you want to put your cursor and click on the cell B, column B, and cell A8. We're going to make that cell sum up those 6 numbers. So whenever you ask it to do anything, you have to start with equals. So you're going to have an equals, and we want it to sum, so we're going to type the word sum, and then parentheses. And it's asking you to tell me which numbers you want me to sum up, which cells. Well, it's actually B2 to B7, but you don't even have to type that. You don't have to type B2 to B7. You can just click, well you guys don't have a left click because I have a mouse, but you want to left click or highlight B2, and then you want to left hold, like it would be on your mouse, and drag that down from 55 to 52, and hit enter, and it'll sum it up for you. Now there's another way of doing it with formulas. Anybody ever do it that way? With an auto sum, and that's a little more advanced, and if you know how to do that because you've already used it in like Mr. Ronalds's class or something, that's fine. I'm just trying to stay basic for right now. So it just added up those numbers for me. So I go in the green column. Now I could drag the formula over, but I don't want it to sum up the next couple columns, so I'm just going to do it again. If I come over here in the green column under 98, I'm in cell E8. I'm going to add up those. So I'm going to say equals sum, parentheses. And then I click on the 77, make sure you get the white cross, drag it down to the 98, release it, and hit enter, and it adds it for you. And you could do that for the other trial. So each trial, I'm seeing what those add up to be. So I'm going to get trial 3 and trial 4. And I broke it apart with this piece of information because in some of the higher level significant tests that you'll be doing. Oh, what did I do? It says negative. What I hit a negative sign. Mrs. Braska cannot see with the lights out. Okay. Please forget all. So, well, I know that's not right. I know it's not right. We can't have a negative, right? Because none of the problems were negative. None of the points were negative. There's a test, I believe it's a chi-squared significance test, or it's an ANOVA. It's these 2 different significance tests that I'm looking at that some of the level 3s will be using and you'll be using in your research eventually, that you have to go through and find different things. You have to find the sum of your data, the mean, the standard deviation, and you have to take each piece of the data, subtract it from the mean, square that number. There was all these different parts to it, and I thought, well, I don't want to do the whole test because that's really involved. So I just am taking certain pieces of it so that eventually someday when you have to do the bigger test, you'll know how to do some of the smaller pieces. Okay? So that's just finding the sum. And if you know, like I said, the auto sum, you can do it that way as well. If I wanted you to find the mean or the average, normally what would I do with all my numbers? Add them all up and get the sum and divide it to find the average. So we can actually have the program do that for us. So if you go in the yellow column, B9, put your cursor there, we're going to find the average. It's going to be equals. We always got to start with equals. Average, parentheses, whoops, open parentheses. And then the same thing. Highlight the 55, down to the 52, release it, hit enter, and it'll give you an average. And if you screw anything up, it'll tell you. It'll say the formula is right. Or if you don't like what you did, I love this button up here next to save. I love undo. Undo, and then I undo it. Oh, no, I did it right, redo. I love undo and redo, because as soon as you screw something up, you can just hit that. So if I find the average of the green column, equals, average, open parenthesis, highlight E2, drag it down to 98, hit enter, gives you the average. We'll do it for, well, we're going to type average, we'll do it for the blue column. And you can type H2 to H7, and that probably doesn't seem like a very hard thing for you to do, but how about if you had 50-something pieces of data? It might just take you too long to type all that stuff in, so it's just so much easier to do it this way. And I'll do the right one. Equals average. Enter. And the other thing when this class right now is over, I have a whole document with all the answers already on it. I'll put that also on Schoology, so if I'm going too fast or we don't have enough time, you can do this again yourself, and then you'll have the answers already there, and the formula is going to be able to see everything. Standard deviation is something that you're going to be asked to find in your science classes. And I have the definition here. It's just a measure of how spread out the data is. Okay? If your means are the same or very close, the standard deviation tells you how spread out each data set is and which data set is more significant than the other. It's useful for identifying a standard way of knowing what is normal if something is too big or too large. So it's you're going to be finding standard deviation, how the data deviates from the norm or spreads away from the mean, basically. And then it says here, a low standard deviation indicates that the data points tend to be too close to the mean, and a higher standard deviation indicates that the data points are spread out all over. It's like a spread out range, okay? And then there is something about standard error, and I'll talk about that in a minute. To find standard deviation by hand, you would have to take the average, which we just did, if you had to do it by hand, not with the computer, then every single number, 55.7, has to get subtracted by that. So you'd have to take 55 and subtract 55.7. And then you'd have to take 57 and subtract 55.7. By hand, I mean, you could use a calculator if you had to. Then take all those numbers and square them. Then add all those up. Then take their average and take the square root. That's how you would do it by hand. It's a long process. So you can get that number by typing in equals B in the cell B10, ST, and then DEV for standard deviation, parentheses. And guess which cells we're going to use? B2 down to B7. And what that means is 68% of the data, these are two numbers you use with standard deviation, 68% of the data and 95% of the data. But 68% of the data is either plus or minus above 7, above the mean, 55.7, or below the mean. And that tells you, like I said, how spread out the data is. So that's a piece of information that you will be using when you have your, when you're taking the design classes, or maybe have done it already. The other thing I want to show you is how can I subtract, like I was saying earlier, how can I subtract every single piece of data set, 55, 57, 47, 55, 68, 52, from the mean? And how can I do that without having to type it in every single time? So what's my shortcut? Okay, so I'm going to go up to my C2, right here, and I'm going to hit equals. And I want to subtract 55, and that's in the cell B2. Now, don't do what I'm about to do. Minus B9, because B9 is the cell where the mean is. Well, you're probably thinking, well, why wouldn't I do that, Ms. Prohaska? That's right. 55 minus 55.7 is a negative 0.7. It's right for that cell, but do I have to keep typing this down every single time? No, maybe I could just drag it. Can anybody ever do that? Just like drag a formula down, which you are allowed to do in Excel. If you take a little cross like this and you drag, it will drag the whole formula down. But guess what happens? I don't get right information. Wait a minute. Look what it did here. It's not subtracting it every time from that 55.7. So, undo. In order for you to get the right information every single time, we're going to still do equals. we're gonna do B2 minus B, and you're gonna use a dollar sign, which is above the 4, 9, which is the B9 cell, enter. Now I know it gave me negative 0.7, it's the same answer. But what happens is, when you take this little black thin cross and drag your formula down, it gives me all the right answers now. It keeps the B9 for every single cell. If you don't do that, did you notice the next formula said B3 minus B10 and then B4 minus B11? Like it was all the wrong numbers to subtract it from. So what that number sign does, bless you, is it keeps the same cell every single time. Okay? And Mr. Moraski was in here, the science teacher from the middle school. He said, I never knew that, and I used Excel all the time. I go, I never did either, and I used Excel all the time. It's just a constant, it keeps it constant. And then what we're going to do is we're going to square all those numbers. So to square something would be to times it by itself. But I'm going to do it in a formula so that I can drag it and not have to type the same thing each time. So in the D2 cell, we're going to hit equals. I'll start with the first one, the negative 0.7, so I'll do C2. I want to square it. To raise something to the second power, you want to use, I call it a caret. I don't know if that's the right word, but it's above the 6. It's a little upside down V. Yeah, I think you may have seen on calculators. And you hit, especially your graphing calculators, and then you hit 2, because what I'm asking it to do is to square that cell, and I'm going to hit enter, and it squares the cell. Squares the number for you. And now I don't have to do that every single one. I can take my little black arrow, drag it down. There it is. And it squares them all for me. And I didn't have to do anything with a number sign in this one like I did earlier because I wasn't subtracting a cell. I was just squaring the cell I'm looking for, not subtracting it from another cell every time. And you can play around if you want. Like, let's just do that one with the number sign one more time here in the F column. We want to take the mean, which is 77, and subtract it from 77, which should be 0. So we're going to have E2 minus E, number sign, 9. And we should get 0. And then if you take the little thin cross and drag it down, you should get all the right answers. As I do. And then we can square it in G2. Anybody getting any like number signs or some weird numbers? Okay. I'll tell you. Did you already get number signs? Like hashtags, I mean.
Yep.
Which one? Like right here where the 0, 0 is?
No, for the X mean, 2 for the yellow straws.
Here?
To the right. Yeah.
Okay. If anybody else got hashtags, I'll call them, I guess. If you right-click on the cell that has those hashtags, go down to Format Cell. You should have, it might be under General. What is yours? See all those categories? Which one is yours highlighted on?
I have to redo it because I undid it.
You did it?
Like I did undo.
Oh, you undid
And
it.
then I gotta try again.
So you're doing it again. So you gotta put that back in. What's happening is the cells are formatted to be numbers, be text, decimals, percentages, and it all depends on how that cell is formatted. And you're gonna see that if it comes up with hashtags or number signs, it means that the cell's not formatted properly. And you can just right click on the cell, go to Format Cell, and you want it to be a number with 1 decimal place. Maybe you want it to be a date. No, we don't want a date. Maybe you want it to be time. Maybe you just want it to be general. Maybe you want it to be text. I mean, it depends on how you want it to look. But for our purposes, we want it to be a number with 1 decimal place. Okay? And then I'm going to just square one more time my whole G column. So I'm going to do, or my whole F column. So I'm going to do E equals F2. And we're going to square that. So we're going to put that to the second power squared, which 0 squared should be 0. And then you take your little cross and you drag it down. It'll square everything. Now, I'm hearing from the older kids that have done SRI before, or any of the science projects, that some of the teachers will send them a file that already has all the formulas in it, and then all you have to do is add your data. So it kind of would be the opposite of what we have right now, where it says sum, the formula would already be in there, and you would just have to add your data in, and then it'll already make it for you. It'll sum everything up, total, mean, standard deviation. Just be careful, if you ever get a file sent to you and you have to add your data information, see where when you highlight something, there's a formula there. Be careful not to delete it, because if you delete it, you delete the formula out. Like if I delete this cell right here, B2, I'll just delete that number. See how everything changed? All I'm doing is deleting the number 55 out. Undo. But if I delete this formula out of C2 out, I'm actually changing, I'm taking the formula away, and you just have to be careful with that, because some cells just have numbers in them and some have formulas, and the formulas are more important. It's like, I know that was fast, and I'm not going to do the other ones, but it's just showing you how to do the sum of a column, the mean, difference of two cells, squares, the standard deviation. And then let's go over here to bar graphs and percents. This is pretty basic. So the bottom tab, which is bar graph and percent. I'm going to show you how the program will autofill for you when you want to put months in. Like let's say you're looking at something over a calendar year. Instead of you having to type in January, February, March, April, May, what you can do for month is type your January, Jan, in A2, and type February, FEB, in A3, and that's enough typing. And then you can highlight January and February, get a little black cross, drag it down, release, it'll fill the rest of them in for you. Let me see, do it again. So after you type in January and February, you need at least two, so the computer knows what you're doing. Highlight both of them, over here, get the little thin black cross, bring it down. Well, I typed them all in, it's already there for you. So what I did was, I filled in the days of the month, so in January, there's 31 days, and then this is next school year, off the next school year's calendar. So next school year, January 2019, you're gonna go to school for 19 days out of the 31. So let's see what percentage that is. So let's move over to the gray, purple, whatever that is, column. We're gonna do equals. So to make a percentage, we're going to divide the 19 by the 31. So you're going to take C2, divided is where the question mark is, B2. And you get a big long decimal like that. I don't want that big long decimal. Plus I want it to be a percent, and maybe with only 2 decimal places. So what we can do is, as I was showing, because I feel like I know your face. Okay. What's your name again?
Dan?
Dan?
Yep.
Dan. Dan what?
Wireball?
Oh, nothing. Yeah, you have a brother.
No.
No, you look like somebody. Okay. Yeah, you look like somebody in this world. So, as I was saying to Dan, we can format the cell. So let's format our cell before we drag the formula down. So get your white cross, your cursor in there, right click, go down to format cell. And it should say general, but I would like it to be a percentage. So let's go down below time. And I would like it to be 2 decimal places. You may need 3 decimal places. It's all up to you and what your data is going to look like. Maybe no decimal places. It's up to you. And then hit OK. So in January, next school year, you will be in school for 61% of the time. In that month. Let's drag that percentage down and that formula down. I'll have to retype this again. So I have my little black cross, drag it down. Oh, I didn't do my totals, I have to do my totals. Each month, oh, there's a real nice month in there. What is your favorite month out of that one? Gotta be...
February.
No, July. Well, of course, July, you're not in school. So February, you're in school 67% of the time, March 67, April May 70. May you're in school most of the time. June just a little bit, July not at all. Now this is August, this is for the beginning of this school year, because I did like August to June, July. August you only go to school 4 days, that is actually the time that you spent in school, so it's 12%. September, 63, October is always a big month. And look at December, such a little month. Let's sum our days of the month up. Now, what number should that come out to be if I add up all those days? 365, let's see, equals sum, parentheses, and we'll highlight 31 down to 31 and let go, and we're not doing a leap year. So 365, which is right, because there's 365 days in the year. Let's figure out how many of those are that we have to go to school for. Oh, you know what? I'm not even going to waste my time. I'm going to drag my formula over. All I wanted to do is to sum up the next column, just like I did the B column, so I can take my little black cross and pull it over there. I can just grab that formula. So you have to go to school next year 183 days. That's how many you went this year. Well, you actually didn't because of all the snow. The teachers made up like 4 of those days, so you're welcome. You only went 179 or something. Maybe you went 180. You did do that one Friday PLT day. So you did 180, which is what you have to do for the state. But you really are going to go to school next school year 183 school days. And then we're going to look at the percentage of days that you go to school in January for the entire year. So let's divide, let's do equals. Let's take 19 days in January, which is our C2, and divide that, use that number that's the question mark, by 365. You're going to get a big long percent, or decimal, which we won't want. We want to change that to a percent. So I'm going to right click, format cell, same thing, I want to go to percentage and 2 decimal places. So out of the entire year, 5% of the days are spent in January. And I'm going to drag my formula down. So the biggest percentage of time when I'm in school is May and October is the biggest percentage of your days. How many days total percentages would you be in school? Like we know we're in school 183 days. What percentage of the days is that? Well, I'm going to sum that column up and see. So how many days do you think you're in school? What percentage of days? You know you're in school 183 days. What percentage do you think that is? It's only 50%. Doesn't it seem like you're in school so much more? Like physically at the school, you're only in school 50% of the time. Obviously, you're in school, like if it's a weekend, you're still a school student, it's the school year, but you're not at school. So you're only really at the building 50% of the time. Now you guys are probably here way more because you're involved in a million different things. So that's just some percentages to or decimals to percents and how you format a cell. And once you get used to it all, you know, that'll come way easier to you. I just want to show you, if you hit this little plus button, that's a new sheet. That's what your Excel sheets look like. They're completely blank. And then you have to design everything. You've got to make columns, you can make them bigger, you can put bars around them, things like that. I mean, there's all different things that you can do to make them colorful, but that's for you to design, okay? That's that sheet one. So then go down there where it says mean, SD, and SE. So we're going to find the average, the standard deviation, and then talk about what standard error is. So this is just some 2 data sets that I pulled off of the internet. We're going to find the average or the mean. So if you're in B16, you want to hit equals average, parenthesis. And we're going to find the average from, I think it's B5 to B15, just like we did it on the other page. And hit enter, and you're going to get a big long decimal, and we'll just leave it like that. The more decimal places, the more significant it is. The more you round it or truncate it, it's less significant, so you can just keep all those. I don't have to retype that over here with the data set too. I don't have to do that formula all over again. Take your little cross, that cross, go to the right with it. There you go. It's very, very close in significance, or in mean. The means look very, very much the same. We're going to check their standard deviation now. So we'll do our equal sign if you're in B17, ST, DEV, parentheses. So you want to find the standard deviation of B5 down to B15 again, and hit enter. 68% of the data points are plus or minus 3.8 from the mean, either above 4.5 by 3.8 or below it. And then we can just drag it over. Okay. So the standard deviation is, even though the means look very much the same, 4.5 and 4.4, the standard deviation is slightly different there. And then we're going to find standard error. Now I gave you that definition because that's a little involved, and I'm going to read it. The standard error is very similar to standard deviation. Both are measures of spread. The higher the number, the more spread out the data is. To put it simply, the two terms are essentially equal, but there is one important difference. While standard error uses statistics, meaning a sample data, standard deviation uses parameters, which is the population data. In statistics, you'll come across terms like the standard error of the mean, the standard error of the median. The standard error tells you how far your sample statistics, like your sample mean, deviates from the actual population mean. The larger your sample size, the smaller standard error. In other words, the larger your sample size, the closer the sample mean is to the actual population. What that means is, let's say you have, I'm going to use Rachel Kisselring's examples. She has tens of thousands of pieces of information, and we have to take that information and run some tests with it. We're not running it with tens of thousands of pieces of information. We're taking a small sample. So that we want to see how that standard error comes out, because if we want to see if that represents our data set well, because it's going to be too involved to take it of the entire population. So you want to make sure that the standard, what does it say? If it's larger, if the sample size is larger, then you want your standard error to be smaller, because you want it to represent the whole population. It's like when they say they survey people, when they do polls and all, do you think they survey the entire population of the United States? No, they take a small sample size. So you want that standard error not to be smaller, because that means it's more accurate. So I know that's a lot of terminology for you, but it's some things that you will look into. It'll make more sense when you're doing your charts. In fact, were you guys all watching the STEM presentation? Maddie was actually talking about it when she showed her graph with the fungus growing, and I'll show you that when we do our bar graphs. Okay? But to find standard error, there's a little formula. And when I give you guys, when I put the actual answer key on Schoology, all you gotta do is click on that cell and it'll give you the formula. So we're gonna do an equal sign parenthesis. We're gonna take the standard deviation, so that's B17, that's the cell, divided by, and we're gonna take the square root of the amount of numbers that we actually have in our data set, which is 11 numbers. So to take square root, you're going to do SQRT, square root. There's 11 numbers in our data set, so we're going to do parenthesis 11, close the parenthesis, oh, I didn't close it. Then we have to close parenthesis one more time to have the whole thing after the equal sign in that parenthesis and hit enter. And that would be our standard error. So we took our standard deviation and we divided it by the square root of how many numbers are in our data set. And that's the standard error. Now, instead of having to do it again, I'm going to pull that formula over to the right. I'll put it back up there so you can see it. B17 or C17 divided by the square root. I closed my parentheses twice because The first parenthesis closed it for the 11, and the second parenthesis closed the entire thing. I know, much more complicated. Alright. Rushing through this. Last thing is the graph, with a bar graph with something called the error bars. Okay? And I have that on your paper, kind of defining what they are. So error bars are graphical representations of the variability of data and used on graphs to indicate the error or uncertainty in a reported measurement. They give a general idea of how precise the measurement is, or conversely, how far from the reported value the true value might be. Error bars often represent one standard deviation of uncertainty, one standard error, or particular confidence interval. These quantities are not the same, and so the measure selected should be stated implicitly in the graph or the supporting text. There's a little picture of it below, and like I said, Maddie had this in her presentation today when she was showing the fungus, how it grew without any of the bandages on it or whatever she used for it, those different bandages, and then they were all kind of smaller. And I don't know if you noticed those bar graphs had little sticks kind of off the top of them, and that is the graphical view of the error bars. And I know that Ms. Shade said they have to know how to put these in. So right now I'm just going to show you how to do them, and then when you do your science, you'll understand it better when you put it all together. So I'm just going to show you the math part of it. Okay? First I'm going to make a bar graph. So again, I have the data here for you, and we're going to make a bar graph. And all we're going to put in when we make the bar graph is, we're going to put in the mean and the standard deviation into our bar graph when we're highlighting all this. All right, so we're going to take, let me think of, so the mean and the standard deviation is very different. We're going to highlight from A8 over to C10. And there's the titles when you walk to run and run to walk, and the mean was already found and the standard deviation was already found for you. Then we're going to go up to insert, and your recommended graphs are right here. Insert a column chart. And I think we're just going to do a two-dimensional one. You know what? I don't want the standard deviation. I don't want the other bar. I don't want the orange bar. Undo. I'm only going to do the mean. Insert. That's better. So I only highlighted the means, walk to run and run to walk. And you can do different things on here, like I could call this, I'm going to teach you how to put some error bars on here. Give it a title, something like that, if you want to. Jazz it all up. You can give the vertical axis over here, it's miles per hour. It's talking about walking to run and running to walk. So you can give that a title if you want. You want to add some elements over here on the top left. It says add chart elements. We can add an axis title, and we can add a vertical. We want to add something over here. I don't know what you want to call it, like speed, miles per hour. You can make it different fonts and miles per hour. So this is all up to you and how you want to design it. I'm sure you can make your bar graphs different colors, but we won't worry about that right now. So this would be something that, as I said, Maddie had in her report when she was talking about the fungus growing, and that's why you have to know how to do these things, because you're going to need to put that in a report that you're going to have to present for science fairs or to your teachers or whatever you need to do. So that's just how you would add that element if you wanted to add a vertical title. So now let's put these error bars on in. So, all right, let me see if I remember. Just click on my graph. And let's go to design. Let's see what format is. No. Let's go to design. And chart tools, and we're gonna add a chart element that's over here on the left. And you would think it would just be, you're gonna just hit add error bars and they're just gonna add them in. But even Miss Kissling said, I wanna see how you do that, because when I just did it this way and added them in, they weren't correct. And I'm like, I know, I watched a YouTube video and they told me you have to go down to error bars, go down to more error bars, and then where did I go here? Down all the way to the bottom to custom. And then it'll say specify value. So what you're going to do now, you're going to put a positive range in here, error value, and you're going to take your standard deviation. So you're going to select these two cells, the two cells that have the standard deviation in it. You don't do anything with the negative. You hit OK. And they don't want, most of your scientific research, they said, doesn't need the negative part of this bar, and the negative part of this bar is the part that is inside the blue column. So they just want the plus side. So you hit plus, it says both minus and plus. And it shows you that even though their means are very close, their standard deviation shows that some of the data on the left is spread out more than the data is on the right. And your scientific research and your papers are going to want these kind of things in there. You want me to do it again? I'll do the whole thing again. What? So I'm just going to take the mean, I'm going to insert a two-dimensional graph. I'm not going to add any of the labels on. All right, now I want to add my error bars, more options, custom, specify range. I want to take the standard deviation from this cell and that cell, hit OK, and I'm all plus. And those are what are needed for your graph. And how the length of those actually means something. If something is more spread out or closer to the mean. I know that was like a whirlwind presentation, but that is something that you'll be using in your scientific research. And I'm so glad we actually watched that today and watched them present. And when Maddie was talking about it, I'm like, ooh, that is something that they're going to need to know how to do. So now that you're proficient in it, but at least if you get to your ag classes, you can at least say, all right, Miss Braska said something about that, something about those bars. I don't really remember what she said, but she said something. You know, the SRI program is here for you guys this summer, but it's not like we're going anywhere. So you know where my room is. Well, no, who doesn't know? Some of you don't know where my room is. Well, you do, and the older ones do. I'm up in the math wing. So if you're in class and you're learning about this and you're going to have to put this in a report and you forget, then you come see me. And we're going to be having this, PLTs, the personalized learning time. So, just come find us and we'll help you. Once you know the science part of it, then you just bring it to us and we'll help you put the math part in. I don't know if that would have helped you last year when you had this class, I don't know, or 2 years ago, but now we're here as a resource for you. Okay? So, you don't have to save anything. What I'm going to do is I have a file that has everything in it already, all the formulas, all the answers, level 2 statistics, and I'm going to add that to your page here. So your student files is what you just went into. I'm going to add kind of my answer key, if you want to call it that. And then you could, if you wanna practice, play around, just say, I wanna see if I can do some of that stuff again that she did, get it to look like hers, you know, you could totally try that and you'll have it all there. So if you did look at it and you downloaded it, it's the same thing you just did with all the answers. Enable content, see? So everything's there. Oh, see that was another example I was gonna use about final exams and standard deviation sample size, but hey, it's there, it's a resource. So everything's there with all the formulas already in there. Oh, there's another bar graph I was gonna do with this information. So it's up to you, you know, if you wanna look at it and play around with it, okay? All right, any questions for me? So you guys can log out. Thank you. And put your computers back, and then that's it. It's 10 to 2. I'll be back next Wednesday. So if you have any questions or anything, always send me a